This is section 4, rates of change, example 6. So for example 6, we're doing the exact same thing we did with example 5. The difference is that now we have a square or quadratic function when we're talking about our position. So if s of t is t squared minus 2t is a measure of feet traveled with t measured in seconds, find the average velocity and the instantaneous velocity. All it means is that our instantaneous velocity is going to take a little bit more work. That's all. The average velocity is still the slope of the secant line. So we're finding s of 2 minus s of 0 over 2 minus 0, which means all we're doing is taking 2 and plugging it into our equation. So that means we have 2 squared minus 2 times 2 minus 0 squared minus 2 times 0. Well, you know what that is. That's just 0 all over 2. 2 squared is 4. 2 times 2 is 4 over 2. So that's 0 over 2, which is just 0. So it's 0 feet per second. For the instantaneous velocity, we're finding the limit as h approaches 0 of f of x plus h minus f of x all over h. We're plugging in 2 because that says that t equals 2 seconds. So we're finding the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. Pen stopped working. Equals the limit as h approaches 0. Now, this is where we have to make sure we're plugging it in appropriately. We're plugging 2 plus h in every time we see t. So we're going to have 2 plus h squared minus 2 times 2 plus h. Because we have to plug 2 plus h into the entire equation. Now we're plugging in 2. So minus 2 squared minus 2 times 2. And that is all over h. Now we'll do some multiplying and simplifying. So 2 plus h squared is the same thing as multiplying 2 plus h times 2 plus h, so we have to use double distribution. So we have the limit as h approaches 0 of 4 plus 2h plus 2h plus h squared. Then we distribute this 2, so we get minus 4 minus 2h, and then 2 squared minus 2 times 2 is 0, so we don't have to worry about that. And that is all over h. Now we cancel. So 4 minus 4, those cancel. Hey, look, we have a negative 2h here and positive 2h there. So we end up with the limit as h approaches 0 of 2h plus h squared over h. Both terms in our numerator have an h, so we're going to factor that out. So we get 2 plus h over h. Those cancel. So we're finding the limit as h approaches 0 of 2 plus h, which is just 2. And it's 2 feet per second. And that's it.